So this section looks at developing a resource which could help a student to overcome a difficulty they may have within the topic. So my topic is the hyperboloid of revolution, and I'm going to look at how we could make a simple model to outline some key principles within a hyperboloid of revolution, and it would also help students to visualize this. So a little model I've made up here, it's just a simple model of, firstly it just looks like a cylinder, so using two little discs made from cardboard. So we're going to call this our top circle and this our base circle, and these two circles are joined up just with straight line elements from matchsticks. We also have our axis here in the middle, which is our fixed axis, and this is outlined by our blue matchstick. So to begin, I'd like to think of a hyperboloid of revolution simply as a cylinder which is twisted or pulled out of shape. So you'll start off with your cylinder, two circles joined together using straight line elements. This will allow students to familiarise themselves with it from the start because they'll be familiar with such shapes as a cylinder. Okay, so then how do we go about forming a hyperboloid of revolution when we have a cylinder and we have these straight line elements joining it together? So a hyperboloid of revolution is formed when one of these straight line elements, as we see here, is rotated about our fixed axis or our blue matchstick in the middle. So if we go about twisting these two circles and rotating one of these straight line elements around it, we can see the shape of a hyperboloid of revolution beginning to form. So you can twist it as little or as much as you want, and it'll all give a hyperboloid of revolution, just of different shapes. So firstly, that's how you go about constructing it. So just simply twisting your straight line elements around your fixed axis to form a hyperboloid of revolution. Now a few more principles behind this. So along the center of your hyperboloid of revolution, you will have your smallest width. So this is going to be known as your throat circle. So the smallest circle within your hyperboloid of revolution will be known as your throat circle. Now your throat circle and your straight line elements have a relationship. So the straight line elements are always tangential. So you can see that if your hyperboloid of revolution is like this, then your straight line elements will be tangential at the throat circle here. And if we twist it more, then they'll be tangential here. So also these straight line elements are always going to remain parallel. So if we look at them in the form of a cylinder like we can here, we can see that all of these straight line elements are parallel to each other. Once we keep twisting them around, we can see that no matter how much you twist them, the lines will still remain parallel to each other. So a simple model like this can be used just to outline the straight line elements method of creating a hyperboloid of revolution and just the principles behind it. I think by starting off with something simple like this in a cylinder, students will be able to develop their knowledge and familiarise themselves with something they know about already. You could also use this model as an activity within the classroom when introducing students to the topic by giving them out matchsticks and cardboard like so. And once they go about constructing a model themselves, they'll be able to familiarise themselves with this topic and make it easier to visualize a hyperboloid of revolution to them. So that's my physical resource. So simply create this model, and we have the straight line elements which are rotated about your fixed axis in the middle, and this will ultimately create a hyperboloid of revolution.